Hello guys, so I watched Storror last video and I wondered if I could locate it using OpenStreetMap data mining tool overpassturbo. Let's start with OpenStreetMap. It's a free, open map database created by volunteers from all around the world. You can think of it as a Google Maps alternative, but the data is much more detailed. We will use overpassturbo to find the bridge by describing it and its environment. Overpassturbo is a data mining tool that allows you to request OpenStreetMap data using Overpass API queries. The results will be displayed on the map. What you see right now is the final request with the final result. As you can see, we managed to find the bridge. But let's start from scratch to understand how we got there. Here, we requested every bridges in the area we are looking at. As you can see, there's too many of them for this result to be useful. But let's explain the query first before we try to refine the results. So it can be complex if you have never seen this before, but it's not too difficult. The first line indicates the format of the data and the timeout we want. The timeout is just how long do we wait before we stop the request if we haven't received a result. You will not have to change this line ever again, just keep it like this. The second line is the body of the request. This is what you will change when requesting something different. NWR means nodes, ways, relations. This just asks for every type of data that there is. After that, we have bridge between brackets. This is a filter. It says to only retrieve data that has the property bridge. It could have been bridge equals yes, but when the property bridge is present, its value is usually yes. When requesting bridge equals yes, we are actually requesting only data that has the property bridge and the value must be yes. The second part of the line is bbox between brackets between parentheses. This is just special syntax. It says to only take data from the map we are watching right now on the right. So it's important to be zoomed in, otherwise you might request data for the entire world and your browser tab could crash. Here, I made sure to zoom in on Sussex because I knew Storror members are from there. I made sure to avoid London because it has a lot of data. Vbox is also something you rarely want to change. The third line is requesting to show the data on the map when it will be done. If you are trying to learn how to use the tool, or if you are curious, you can go to the website and give it a try. The first page that will open will have something very similar. Make sure to stay zoomed in. Click Run to run the request. You can edit the text on the left to modify the query. Try to the URL of the website should be shown on the screen, or you can just search it on your favorite search engine. This is the first request that the website show when opening. If you are watching the video in the future, the request might have changed, but the concept should be similar. Click on Run to run the request. The result should look like this. You can click on the nodes to see their properties. Now, if you want to practice a bit, try to find the bridges in Rome by modifying the query and zooming out a bit. Click pause now if you want to find the solution yourself. This is what I got. You might have something different. If you look at it, I edited the last line to be able to display ways on the map. Let's go back to the Storror bridge. I opened one of the nodes to analyze his properties. The interesting property here is surface equals wood. Let's open the Storror video and see if we can figure his surface. As you can see from this point of view and other shots, the bridge has a surface made of wood. We are going to use this to filter bridges that are not made of wood. This is what I got. As you can see, this is much better. Let me explain what we have changed. I added surface equals wood between brackets. This is the same concept that we had before with bridge equals yes. We are only accepting elements that have the property surface and its value must be wood. You can continue filter elements like this by adding more brackets with more filters. But we still have too much data to look at. Let's see if we can reduce the number of bridges even more. What I found is this: some bridges are not above water. This one, for instance, is above a railway. You can see it in Google Street View. This is what it looked like. As we can see, there is still a lot of data, but some have been filtered. The bridge we clicked at earlier at the bottom is not present anymore. So the filter has worked. Now let's explain the query. The request has become a lot more complicated. Let's see what has changed. The first line of the body is the same, but we are assigning the result to a variable named bridges. A variable is a symbol representing the data. Here it will contain the list of bridges that we had requested. In the second line, we are using the keyword ways. It is similar to NWR from before, but this time we are only requesting ways, which are essentially lines. After this, we are using the operator around. It helps us filter the data by only looking at nodes nearby. We are specifying to look around bridges and the distance must be 0. A distance of 0 essentially means above the water. After this, we are specifying that we are looking at waterways, essentially rivers and canals, and it must not be a tunnel. After this, we are indicated that we are assigning the result to a variable named waterways. A variable can be any name you would want. Waterways made sense here. The line after is essentially used to select bridges near the waterways we have selected. We are assigning the result to a variable name match. The line after this indicates what data we are displaying. We are displaying the matches. We have still too much data, so I thought of filtering for long bridges. Here is an instance of a small bridge. So let's see how to do this. Here we have made a small change to the request. At first, when requesting the bridges, we have added a filter. The filter is the part between parentheses and essentially requests bridges with a length superior to 20 meters. The first part is the operator if it is indicating that the elements must match this condition. The condition is the text after the word if. Length followed by parentheses is a method. A method is a dynamic operation doing something on the data and / or returning a value. Here it returns the length of the element, the length of the bridge. Then we have the operator superior to, represented by the angle bracket character. It indicates that the value must be superior to another value. Here, the value is 20 meters. We don't have to specify that we are using meters, it's always meters. If you are used to measure distances in word units such as the size of your feet, I will recommend that you switch to meters like the rest of the world. Leave a comment if you like meters too. Here is a bridge we found this way, for instance. It is indeed a long bridge. We have greatly reduced the number of bridges and we could try to look at them manually. But let's see if we can reduce the number of results even more. Here I isolated a frame where we can see a power line in the background. You are probably wondering if the power lines can be found in the website. Yes, you can. It's pretty impressive. Here the request is essentially asking to return data that has the property power in it. Value must be tower. There was not too many bridges left, so we could have looked at them manually using the power lines results. But let's see how to integrate this into our query. This is the final result. We have reduced the number of potential bridge to 1. Let's explain the query. There is essentially nothing new here. The first line we have added is just requesting power lines around the bridges we have found and the distance must be 100 meters. I had to set the value iteratively. I had picked 50 meters at first, but this was clearly too low. The second line just reassigned the results to the variable match. And then, we are displaying the result as usual. Let's see if we have identified the right bridge. Here is the map zoomed in. The bridge is east of southeast. It looked like a good match. I opened the node and I noticed that even though his name is Southeast Bridge, that there is a note indicating that it used to be a swing bridge. A swing bridge is a bridge that can open for boats. So it has nothing to do with swinging. What is interesting is that there is swinging on a swing bridge. It was in the title, which is kinda funny. I had not even noticed it. Maybe because it's not one anymore. You might be wondering if we could have Googled it knowing this. And the answer is now. Search results in Google are often pretty bad. This is why I like doing this type of search in OpenStreetMap. The results are much more precise. Anyway, let's see if we got the correct bridge. And it does look like it. That is pretty nice. It's truly incredible that we managed to find the correct bridge by analyzing the power lines and the surface of the bridge. Let's see what else we could have analyzed. This is a request that asks for every nodes in the region without any filters. Do not use this on a big region. You must be fully zoomed in. Otherwise your tab browser will crash. We could have requested a bridge with a gate nearby. We also could have requested a bridge with a dock around it. There is also a bench close by, but I am not sure if we have seen it in the video. There is also a meadow on the hill near the location. There is also a lane for bikes. But every time you add something, you need to be aware that it might not be present in the data. For instance, sometimes trees are indicated but not always. Obviously, another way to find the bridge is to do a visual search in a visual search engine. Here I use Google to do it. But, as you can see, the first results were not the right one. It could have been completely missing. And sometimes there is a brand or something similar in the way that make the visual search return terrible results. If something is written, it will often return something related to the text and not the image. For instance, here I requested a search from a specific frame and Google had no results. But after changing the frame, it does return the right result. This time the result is in first place. The voice of the video was made using TTS. This is not a sponsor. This is an open source tool allowing people to generate speech from text. It's pretty cool and it's open source. Let me know in the comments if the voice was good or not. I had picked because it sounded nerdy, but in the end maybe I find it too nerdy. If you liked it, go to their website and download it. You can also give them a star on GitHub. I found it cool to be able to find something very specific by just describing it inside OpenStreetMap. It's a wonderful tool and is incredibly useful. If you liked the video, make sure to comment, like and subscribe. Next time we do a video like this, we will try to figure out where the scene is taken. This is from Dexter Season 2 Episode 5. The episode is named The Dark Defender. In this episode we can see multiple times this marina where Deborah and Lundy are eating. The results are pretty insane yet again. Can you guess what we will be using this time? Thanks for watching and have a good day.